Development of Conjunctive Decomposition Tools by Igor Shubin. Introduction. Among the many formalisms applicable to one degree to another or to the task of processing informal information, the most appropriate is the use of predicate algebra, system of equations which are technically implemented in the form of logical network. One of the advantages of this approach is its direct applicability to all the following types of problems, which is provided by the declaratives of the logical network as a method of solving systems or predicate equation. The notation of the predicate equation itself becomes possible due to the algebra of predicates. On the example of processing test information by artificial intelligence, we can consider the general classification of tasks that arise in the process of working with primary informal information. Analysis, for example recognition, obtaining from informal information specific parameters necessary to the application of some formalism. Normalization, bringing information to some reference form which is relevant to search for information. Synthesis is the exception of the internal representation of information stored in accordance with the format requirements in a form adapted for human perception and mixed tasks. Another advantage of logical networks is wide parallelization of calculations. In addition, the brain-like computer based on the technology of logical networks is close in structure to the structure of the human brain, which gives a reason to hope for the creation of information technology-based systems based on capabilities of human. However, today the theory of categories still does little to solve problems such as description of the mechanisms of human intelligence, such as the development of artificial intelligence, the creation of parallel computers, intelligent radar systems, and so on. Therefore, it is necessary to establish a connection between the theory of categories and modeling the system based on artificial intelligence using an intermediate field of knowledge, the algebra of finite predicates, by which the predicate interpretation of category can be built. Based on its interpretation, elements of the theory of modified category for the process of modeling the functions of artificial intelligence are developed. Usage of logical networks. A distinctive feature of artificial intelligence tasks is that they are difficult to formalize, necessary to enable the automation of their solutions. Thus, it is expedient to study the universal tool of informal information processing, the human brain, and to model some of its functions related to the tasks based on modern technologies. The essence of the approach is that human intelligence is seen as a logic action and some material embodiment of mechanisms of logic. Works on logical visualization were performed. The main thing is this method is the movement from top to bottom, from a general system consideration to algebraic logical structures, and from them to logical networks, which are the indefinitely by biological neural structures. Unlike the traditional information technology algorithmic approach, the declarative task model is not an algorithm. The task model presented in a declarative form is usually a set of facts, knowledge of facts and rules, according to which actions are taken in fact that allow to obtain new knowledge based on old ones. A logical network is a method for solving systems of predicate equation and has descriptive capabilities of predicate algebra. This property of a logical network is a parallel execution of all elementary logical operations, that is, the maximum possible at the logical level of parallel calculations. This approach guarantees high efficiency in solving problems that are reduced to a logical conclusion or to the solution of logical equations. To formalize the task of processing informal information using logical networks, it is necessary to explore the possibilities of rational application of the algebra of finite predicates. To this end, it is necessary to model the most common tasks from different areas of the subject area. Examples include the areas such as the task of modeling of recognition mechanisms of in-conspiration rather objects. Mathematical decomposition tools. The mathematical tools developed for the decompositions of relations and predicates are designed primarily to create logical networks, which in turn are the basis for building the parallel action computer. The mathematical results of the work can be used to automatic language processing systems, computer-aided design systems for information systems. Logical networks can be effective in creating specialized parallel action devices designed to simulate complex computing systems. For example, a system of complete adequate morphological analysis of natural language text. Mathematical modules suitable for implementation of the form of logical network should be represented by a system of binary actions. In each equation of such system should have two variables. This form of presentation is a logical network model. In this case, the system of binary equations should be compact and possible in order to save hardware resources when implementing the model. Almost all available formal means of decomposition of predicates in these works do not consider the relationship between variables. Taking this feature into the account in the structure of predicate allows one to decompose in a more rational way. Meanwhile, the theory of a relational database offers a mean of decomposing relations informed statement about the dependencies between attributes. Given the deep connection between relations and predicates, the means of decomposition of relations can be applied to solve the problem of decomposition and predicates. As an analysis of the literature has shown, such tools are currently not available in the apparatus of the predicate algebra. The only difference between category theory and the predicate algebra is that the former moves from top to bottom, aims to learn higher logical mechanisms, and therefore uses starting points the concept of recovery level of componentality. The second, starting from the needs of informatization, moves in the study of the same logic of thinking from the bottom up. If it were possible to give a convincing interpretation of the concepts formed by the theory of categories and the methods developed by it, the terms predicate algebra, in a cognitization to bring them closer to informatization, it would be significantly enrich the tools of predicate algebra. It's the algebra of predicates that we are going to use in such an intermediate field of knowledge. A logical network copies a personal actions, but with the only difference that person acts sequentially and network acts in parallel. The network works in cycles. In the first half bar of each bar, the network for each is its equation form k of x and y equals 1. K is a relation given by such equation. Finds first, according to the known knowledge of pi of x about the value of the variable x at the beginning of each bar knowledge, use about the value of the variable at the end of each bar. According to the known knowledge of qeth of y about the value of the variable p at the beginning of each bar, knowledge of pi times eth of x about the value is variable x at the end of each bar. Mathematically, this operation is expressed by following formulas. Obtaining this knowledge is then used in the state of the pole x at the initial moment of its first cycle. The symbol L denotes the number of branches approaching to the pole x. before the beginning of the post bar. Thus, the only result of the logical network is the refinement of the knowledge. It contains also poles according to the original data. With the introduction of theory of categories, along with the usual concept of category, there was a more general concept of objectless category. Let M be some set. Its elements denoted by symbols f, g, I, j, and etc. are called morphisms. Suppose, moreover, that some of this case special operation f of g equals h is given, which acts with m times m in M is called the multiplication of the morphisms f and g. The morphism h is called the product of the morphism f and g. Any morphism E that contains M is called singular or identical if it is satisfied the following conditions. For many f there is M for which contains the product f of E in M, equal f of E equals f. For any f in M for which there is a product E by f in M, equality E in f equals f holds. This definition technically allows the existence of category of many units. It is presence in many units, and only this, that distinguishes a category from other known algebraic structures. The singular morphism EF and EF are named according to the right and left of the morphisms f in M if f times E times f equals f, and f times E times f equals f. Tools based on DCPA. Next, we will talk about the development of new predicate decomposition tools based on statement about dependencies from normalization of relational relations. These are beginning the exact definition of the decomposition procedure with the respects of relational relations and predicates as given. Statements about dependencies that allow decomposition of relational relationships are considered. Their generalization are proposed based on the relations between relational algebra and predicate algebra. Dependency statements are transformed into new predicate decomposition tools. A predicate in the basis of disjunctive conjunctive predicate algebra (DCPA) is usually regarded as an analytic notation of a relation. Therefore, predicate decomposition is a decomposition of a relation at the analytical level, simply manufacturing formulas, where not the relations themselves are processed but the corresponding predicate formulas. We create the concept of decomposition as it is understood in relational databases. To do this, we give the concept of the dependence of the compound, which is used in the theory of dependencies. The first expression is the so-called aberrative restriction of integrity. Other types of dependencies that are used in theory of dependencies, functional and multi-valued dependencies, are special cases of the connection dependency. Therefore, any dependence may R in Re from T allows us to repeat R in the forms of natural connection to their projections from 1. In the category of relational databases, it's usually this procedure that called decomposition of R, based on expression 1. Decomposition itself is carried by deciding the initial relations of different groups of its attributes. This suggests that the projection operation decomposes operator, while composition operator is a natural join. Predicate decomposition. A predicate decomposition of P is the derivation of some predicates P1, P2, etc. based on a predicate P, which is possibly of its reverse recovery from the predicates, which is called the predicate composition of P. An important particular case of decomposition, so-called binary predicate decomposition of P, characterized in each of the predicates P1, P2, etc., resulting from the decomposition of the predicate P, has exactly two significant arguments. If the conjunction shows as the composition operator, then the composition is called conjunctive. The predicate analogues of relational projection operations are existing as quantifiers. Then the predicate analog of the projection conjunctive decomposition will be the quantified conjunctive form of the composition. In the representation of the predicate P is the form of expression 2 will be called quantified conjunctive decomposition. Some methods for decomposing predicates boil down to replacing the original predicate P with some auxiliary predicate P with square, which is built based on the original predicate P by introduction of one or more auxiliary variables y1, y2, etc. The idea of these methods is that the auxiliary predicate P star is constructed or in advance so that it satisfies some required quantifier conjunctive dependence. And then using the exceptional quantifiers, the predicate P star is decomposed directly. This predicate is related to the original predicate B by the third equality. Let us consider the concepts of dependencies and some statement regarding them. The latter allow for given relationships to resolve the question of the ambiguity of project-connective decomposition. Consider special cases. Functional and multivariate dependencies. Let the relations R from area of T be given and X and Y be arbitrary subject of set at R. It is said that Y depends functionality on X if for any two functional data f1, f2 from R from equality f1 from X equals f2 from X, follows the equality f1 from Y equals f2 from Y. If Y depends functionally on X, it is written X to Y, and say the relation R satisfies the functional dependence X to Y, or that the functional dependence X to Y is fulfilled in the relations 4. Let be an arbitrary relation R. It is provided that the structure of the functional dependencies fd from R has the following properties: X, Y, Z, W is a subset of set at R. For fourth and fifth rules given. For the deductive systems defined by these rules, the problem of derivability of logical sequence is algorithmically solvable, which means that the analysis of the structures of functional dependencies can be carried out automatically. Defining predicate dependencies. The functional dependence of the argument x(n)th of the arguments x first to xn minus 1 is the predicate p of x1 to xn is expressed by the following formula. Any functional dependence of the group if predicate variables another group can be specified either by several formulas of the following form, or by one of such formula in which, after implication, there will be a conjecture of several equality predicates. If x and y is subject of predicate variables, and y functionally depends on x, then the predicate p satisfies the functional dependence x to y. Cartesian decomposition. The only justified binary predicate decomposition methods that guarantees the correctness of solvable Cartesian decompositions, which allows the composition of any finite predicates, not just fictional ones. Although the disadvantages of this method were discussed before, we'll consider the Cartesian decomposition as the starting point to find a more relational method, sense of saying hardware resources. To perform it of a predicate P of pre of S, it is necessary to explicitly represent in origin of truth. As such, you can use the PDNF for predicate P. Let the p-teeth be the region of truth of the predicate p, pt from S. Then the 15th statement has place, where R is number of tuples of the relation P of T. According to the Cartesian decomposition method, an auxiliary variable is introduced with values B from B1 to Br that are interpreted as unique names for relations to loops. Cartesian decomposition is performed by constructing the actual predicate and subsequent binary decomposition using existing qualifiers. A principal proposed method of binary decomposition consists of the methods of constructing auxiliary predicates, based on which, with the help of extensional qualifiers, many binary predicates are formed. The latter are the result of binary decomposition of the original predicate. The construction of auxiliary predicates can be performed in different ways, or it may not be necessary at all. From the point of view of the structure in the initial functional predicate, three different situations are possible that determine the sequence of action as a binary decomposition in minimum price. The last and the most difficult situation from the point of view of binary decomposition of the functional practice P of x and z occurs when the dependence z to x model of x2 to xm is not satisfied. In this case, the auxiliary variable is also required. It will be introduced after the system of a special subset of set A is formed. The values of auxiliary variable in this case will act as the names of these subsets. With this approach, on the one hand, dependencies will be built in auxiliary predicates that will allow their binary decomposition to be performed. On the other hand, the minimum required number of the indicate subset will be formed, which will minimize the number of values they are auxiliary variable. As with Cartesian decomposition, the advantage of this algorithm for executing the binary decomposition of functional predicates is the ability to proceed the formula of relation in the whole but in parts. For each complete inverse image, the minimum parallelepiped coverage is selected separately. All available methods of non-equivalent decomposition, for example, decomposition involving auxiliary variables oriented to static predicates or relations. The de-scribed method is no exception. Meanwhile, relations in databases are dynamic objects that are constantly updated. Therefore, non-equivalent decomposition methods are not suitable for use in databases. However, they are good at describing natural language grammar, which, in comparison with industrial and commercial database, can be considered static objects. Inflection model. In the way of creating a logical network that simulates the significant part of natural language, there are several goals that can be described as follows. The first goal is to present the entire model of inflection by a logical network, and not just individual parts of speech. The next goal is to provide a logical model of a word. This model should accurately express the entire morphology of the language, so no size of such network seems quite impressive. The main goal is to provide the logical network with a general model of semantic symmetry processing of the phrases, which should cover most of the language. In order to consistently move towards the achieving your goals, you need to start with a model of inflection. So to date, models of logical networks for the inflectional processing of some nominal parts of the speech of the language are already available. A model of inflections and declarations mechanism of full non-possessive adjectives, a model of inflections of nouns of substantive declarations. Other parts of speech from existing models of inflectional processing are not yet presented in this form of logical network. Cartesian decomposition is a rather trivial way to decompose, so the structure of the resulting binary predicates is very simple. Each such predicate is everywhere defined, surjective, and contains an actuality variable that uniquely determines the value of another variable. The length of the formula of the such predicate is the minimum surjective bracket form of determined as the sum of the errors variations of its variables. In that ways, the main types of dependencies of attributes in relational relationships are considered functional, multivariate, and connection dependencies. Considered assertion about dependencies that allow decomposition of relations are relations. The decompositions of the model of inflectional processing of regular verb-word forms was performed using the method of binary decomposition of functional predicates developed on this work. As a result, a logical network was built for this model. The analysis of the hardware implementation of the constructed logical networks showed that such a network, implemented on a modern, inexpensive programmable logic integrated circuit, works 3 orders of magnitude faster than a computer program that simulates the same logical network on a modern personal computer of average power.